Okay, firstly, thanks very much to Yuri, Cecilia, Adrian and the PSG organising committee for inviting me here today. It really is a great pleasure to be in La Paz, this amazing location. And thanks to you guys for struggling out of your beds after what sounds like a pretty hectic poster session last night. I'm really sorry I couldn't be there. We've already heard at this conference the value of long-term monitoring of seabird populations. And today I will not be talking about long-term monitoring of seabird populations, but short to medium-term monitoring of seabird populations, which is something you don't tend to hear about too much. And it's really a kind of, if you want, an indulgence that I'm going to allow myself to talk about some work we've been doing on gannets for the last 12 years. And at the heart of this work is monitoring. I don't think I need to try and convince anybody in this room that we need to be a little bit concerned about seabirds as bellwethers of change in the marine environment. The canary down the mine is looking a little bit peaky, to say the least. But in terms of actually trying to effectively mitigate the effects of deleterious change, we really have to have effective monitoring in place. And conventionally, monitoring is all about counting stuff. Births, deaths, how many birds there are, and ultimately this is what the decisions should be made upon. But we also know that in many instances, seabirds are characterised by having bet hedging life history, so those population numbers might actually be relatively insensitive to change. So I wonder whether these are the best ways to monitor impacts of change. And the other thing that we do quite a lot of as seabird biologists is to stick hardware on the back of them and find out where they go and what they do. And I don't think this is some kind of revelation, but what I'm trying to propose, I'll get out of you anyway so you can see the screen, is that I think we could use biologging far more as a monitoring tool than we do at the moment. Many of you have lived through the biologging revolution, and this has seen a paradigm shift in not only the cost, but the size of biologging devices, but moreover, huge strides in the analytical approach, which means we can now turn the huge screens of data that these devices generate into meaningful biological information. And for instance, biologging seabirds reveals important information about things such as their distribution, their foraging, migration, energy expenditure, and also reproductive biology and things like resource allocation, to name but a few. Now, often these are the goals of biologging studies in their own right, but I think there's real wins to be gained by viewing these in the context of monitoring. So, for example, we can think of these in terms of marine spatial planning, understanding more about the ecology of individuals, and also, importantly, for example, establishing mechanistic links between environmental change and important fitness correlates. And moreover, the behaviours, the traits that biologging records are potentially much more sensitive, much more variable and responsive to environmental change than the demographic parameters which form the core of most monitoring programs. So what I would argue is that we should maybe use biologging in tandem with conventional monitoring rather more than we do today. And just to reiterate the point, I'm not suggesting that people don't do this, I'm just kind of beating that drum to re-emphasise the point. And for the rest of the talk, I'm going to indulge myself and talk about work on a small island off the southwest coast of the UK called Grasshome. This is Grasshome here. As you can see, it's a very welcoming island. And in 2006, we were provided permission by the RSPB after a bit of arm twisting. And we've been returning to Grasshome virtually every year since then. And I should just mention a few things. This is Stuart Beerhop, and Stuart and I first started working on Grasshome in 2006. He's since decided that working on geese is more interesting than seabirds, but his loss is my gain. And so this is Grasshome down here, but importantly it's home to around 40,000 pairs of northern gannets, that's 12% of the global population, and it's also home to a very picturesque not particularly comfortable, but and also quite smelly campsite. But also there's a passable landing spot at a few places around the island. And in a serendipitous coincidence, your plenary speaker yesterday, Mike Brooke, it's actually his brother Tim, who's the boatman who takes us out to this island and has been doing so for the last 12 years. Sorry, I need to know what time it is, otherwise I get lost. So, my indulgence is going to be talking about work we've done primarily on this island, and it was just a chance encounter. We went out there, we thought we'd try out tracking some gannets, and kind of 12 years later we're still doing it, and this is really just a summary of what we found. And the main player in this story is, forgive me, but it's an Atlantic seabird. We have this is the Atlantic. It's quite large, it's quite large, quite important to us anyway. And northern gannets are one of the conspicuous components of the Atlantic seabird assemblage in the north anyway. They're boreal breeders, they nest mostly in large colonies around the UK, Ireland, but also in France, Norway, Iceland, and in North America as well. And they're these very spectacular plunge divers, and they're also a species which is a success story, which is quite nice. It makes a refreshing change. For example, prior to the Second World War, there was about 80,000 pairs worldwide, but today that number's increased to around 400,000 pairs worldwide. Now, we don't really know why the population has increased this level, but it's probably due to at least two processes. Firstly, a reduction in persecution. Gannets used to be hunted. They used to be hunted for food, for oil. Apparently gannet chicks make quite good shoes. But also there's been big changes in food availability as well. And this bird, for instance, has done a great deal out of exploiting opportunities that fisheries present. So that they interact with fisheries and scavenge on discards quite extensively. I'll come back to that a little bit later on. Although this is good news, there are a few kind of storm clouds on the horizon, and a number of threats. Firstly, there's big changes for the way in which we manage fisheries in European waters, which may have knock-on consequences for species like gannets. But also things like offshore development, particularly offshore wind farms, are springing up all around the coast of Europe. And gannets might, we don't really know, but there might be species that could be impacted by this development. And again, to come back to the focus on biologging, these are quite robust. They're about 3 kilos. They're sort of 3 kilos, but a bit of attitude, a bit bitey as well. And this mass and this kind of attitude, I think, makes them suitable species for tracking. We've looked reasonably hard to try and find any clear evidence of device effects, and so far it seems that they are actually reasonably robust to be safely tracked with a range of different devices. And so the approach we've taken over the last few years has been heavily influenced by developments in tracking technology. Firstly, there's been big cost reductions. I'm sure many of you have experienced these same kind of benefits. So when we first started tracking birds with archival GPS, the tags cost about $1,000 US. Now the same tags are about $50 US, so big changes there. But not only that, there's been a great diversity in loggers that have become available. So we started off with archival GPS. We now have GPS loggers which we can remotely download the information from. There's also things like bird-borne cameras we use, accelerometers, altimeters, geolocators, time depth recorders, and collectively this range of instrumentation means that we can build a really detailed picture of the behaviour of these birds while they're at sea. At the same time as this increase in hardware and firmware, there's been big changes in analytical techniques, so that means that we can really extract meaningful biological information from these screens of data. And the other thing that we've done is to try and combine approaches. So using biologging alongside more conventional techniques, so counting things, measuring things, looking at what they throw up, looking at their feces, taking samples of isotopes and those kind of things, and trying to take a kind of an integrated approach in that regard. There's also been a number of other changes during the time that we've doing this work. So in 2006, I had a reasonably healthy head of hair and was fairly clean shaven. But then something started to change. It took me longer to wash my face, and less time to wash my hair each day. And I suddenly realised that actually after a couple of years of denial, wearing hats a great deal, that actually this is just part of the natural aging process. So, as I said, I want to give you an overview of what we've been doing for the last 12 years, focusing mainly on tracking and linking that with monitoring as well. So I'm going to talk a great deal about the behaviour of adult gannets, focusing on their searching and movement behaviour. We'll talk a little bit about individual and sex-specific differences in foraging. I'll also talk a little bit about how these birds interact with the marine environment in terms of oceanography and fisheries. And also briefly talk about tracking multiple colonies, briefly about immatures, migration, and then finish off with some future directions. Okay, so this little chap is our real workhorse, so many of you will know what this is. It is.
I got you.
Indeed, and I got you. So this is an I got you, it's an archival GPS tag, about 15 grams or so. And these have been the workhorse of our studies over the years. And focusing on adult breeders alone, we've used these birds to reconstruct foraging trips from over 600 trips from over 300 individuals. So this is grassland here, the UK Atlantic, and these are the kind of general patterns over the period for these birds that we've tracked. And to give you some headline statistics, an average trip duration by a gannet is about 20 hours, and we've tracked gannets over a total of 11,500 hours. The average trip distance is about 400 kilometres. We've tracked gannets for about 210,000 kilometres. For a subsample of those birds, we've also put on time depth recorders. And during these foraging trips, a typical gannet will dive about 20 times. They'll engage in V or U-shaped dives. As the name suggests, the V-shaped dive is really just kind of in and out of water. And the U-shaped dive is when there's an active swim phase at the deepest part of the dive. And they're not particularly deep divers, so the dive depth varies from about a metre down to about 15 metres, just for dives for about a second, up to about 40 seconds. So that's a bit of background information. Now, from the outset, we were quite interested to learn a bit more about the searching behaviour of these birds. So how do they find food? How are they responding to their environment? Well, it's a very stereotypical response that you find for breeding adult gannets, is that they engage in a commute followed by an area restricted search. So this is a typical track. This is grassland here. This is a bird that's outbound flight. It knows where it's going. It's flying in almost a straight line, and pretty quickly as well, up to 60 or 70 kilometres an hour. And then often around the distal part of that trip, their behaviour changes. They slow right down, their turning rate increases, and they start engaging in extensive bouts of diving. Then following this period of area restricted searching and lots of diving, they then turn around and head back to the colony again, more or less in a straight line, so these birds know where they're going. And also, if you look across individuals, as Sam Patrick did when she was a postdoc with me, you find that individuals do different things. However, those individuals do the same things within their own weekly routine. So, in other words, they have very strong degrees of foraging site fidelity. And this is an example of 4 birds selected so they look pretty. They don't normally form this kind of equal spacing here. There's a blue bird here with 4 repeat trips, a green bird here, a red bird and a magenta bird. And as you can see, these birds on repeat trips tend to follow similar routes and head to similar locations. And importantly, this foraging site fidelity is not just a response to short-term fluctuations in resource availability. If you track the same birds across multiple years, they show long-term site fidelity. So it seems that these foraging locations are quite conserved. You also find inter-individual differences in search behaviour. So the way in which these birds respond to their environment varies by individual. This is not a mistake. These are reaction norms that show slopes or individual birds, their speed in the top two and their straightness in the bottom two in relation to environmental covariates. On the left, copepods, and on the right, chlorophyll. And this is simply revealing how individual birds respond to concentrations of these potentially important covariates over time. And the key thing is that the individuals have significantly different slopes from each other, so they have consistent individual differences in response to these environmental covariates. So individuals do different stuff. You can use other loggers to infer other elements of behaviour for these birds when they're at sea. So this is some kind of preliminary work that a current PhD student of mine, Beth Clark, is doing, and she's using accelerometry. I'm not going to go into this in any great detail, but suffice to say, accelerometry in this case records movement across 3 axes, across a sway, a surge and a heave axis at high frequencies, and we can use this to reconstruct fine-scale behaviour. I think it's best to illustrate this with a track. So this is a trace of a gannet over about 2 minutes, just on the surge axis, and for this bird we had an accelerometer on its back and also a video camera. So what we could do is we could link behaviour of this bird as revealed from the camera with behaviour as revealed from the accelerometer. And what you find here is that this red trace is the bird in flapping flight, this yellow trace is the bird in passive gliding flight, this big green spike is when it's plunge diving, and this blue area is when it's either sitting on the water or working out to taking off, and this white area is actually where this bird finally takes off from the water. And that means you can have great insight into fine-scale behaviours and potentially link this to a range of different activities. Now this work is very much ongoing, but just to give an example of the sort of things we do, this is data average from 3 birds over the course of their foraging bags. And Beth has just done some time budgets based on these different behaviours. So, as you might expect, gannets don't plunge dive all that often. 0.03% of their time is spent plunge diving. 0.25% take off, unknown flight or weird flight that we can't quite assign to anything. Passive flight, 8% of the time. Flapping flight, 24% of the time. And they actually sit on the water for a rather disappointing 65% of the time. But the plan is to use these kind of approaches to see how these behaviours might vary under different foraging scenarios. Everyone likes to think about sex when it comes to foraging. And we were no different. With gannets, males and females look pretty similar, and they're a pretty similar size. Females are around 5 or 10% heavier than males, but we still thought we'd have a go and just do that let's stick sex in the long and simply explained variation in foraging. I mean, sorry, there was a very carefully constructed hypothesis that we followed. And this is some work done by a master's student, Claudia Staus. And the first thing we did is she quite convincingly showed that females have larger home range than males. So females in red, males in blue. Males tend to stay a little bit closer to the colony, they're a bit more coastal, whereas females are a bit more pelagic. And we quite confidently predicted that this is likely a consequence of differences in reproductive roles. We know that male gannets establish the breeding territory and they come back earlier in the year, and so maybe what happens is they create some kind of halo around the colony that means the females then have to leapfrog that halo when they return a little bit later in the season. This is an object lesson actually where you should stop and start and cease asking questions, because when our current student Beth looked at this in a bit more detail, this proved to be complete nonsense. So I know it's going to be quite difficult to see this, but the take home is that these are home ranges by sex across 9 years. This is 2006, which is this year here. That's the only year where females had significantly larger home ranges than males. In 1 year, it was completely the reverse, and in other years, their flexion just overlapped completely. So that was quite an interesting discussion that Beth and I had about that. However, being a smart, diligent student, Beth said, well, actually, maybe we should look elsewhere. Maybe we should think about this in other dimensional space. And so when you look at evidence of sexual partitioning, in fact, they were partitioning in different dimensions. So there was clear evidence that they were segregated trophically. Males and females have quite different isotopes, and they remain consistent across multiple years, with males tending to feed at higher trophic levels than females. She also found evidence of temporal segregation. So if you look at the proportion of time the different sexes spend at sea, this varied significantly across the diurnal cycle. So this is the proportion of at-sea locations through the day. At night, there's no significant difference between males and females. But early in the morning and late at night, males are more likely, significantly more likely to be at sea than females. And during the middle of the day, that flip-flop, with females being more likely to be at sea than males. So although spatially the sexes were not segregated, it seems they're likely segregated in other accents. Another obvious thing that we wanted to do was try and explain the kind of habitat requirements of these birds, why they're going to where they're going, and oceanography was clearly a good place to start. I'm not an oceanographer, but I'm reliably informed that this is probably a front. Someone tell me otherwise if it's not. But these birds are breeding on the edge of the Celtic Sea, which is frontally quite an active part of the world, and therefore it seemed like an obvious thing to try and see whether these fronts might explain patterns of distribution that we were observing. So I worked with the then PhD student Kylie Scales, and she was using remote sensing to create composite front maps to try and get an insight into habitat structure in the Celtic Sea to see whether this might be explaining the patterns that we find in the gannets. And in a kind of inglorious fanfare in the first pass, she looked at the incidence of gannet searching and related it to fronts in near real time. And there was absolutely no relationship at all, no matter how you kind of bend or twist it, there really was nothing going on there. We went back to the drawing board, and actually, when we thought about it, that didn't make a great deal of sense biologically. If you include seasonally persistent fronts, and these are fronts that last for weeks or months, in some cases they're persistent across years, so this front feature here is actually really quite stable from one year to the next. Actually, gannets are twice as likely to engage in searching behaviour in these high frontal density regions than in non-frontal density regions. So fronts appear to be important, but the key thing is that they need to be consistent in space and in time. We delved a little bit deeper with respect to understanding what the functional significance of these fronts might be, with another student doing some great work, Samantha Cox, and she was looking at gannet dive behaviour in relation to these fronts. And she looked at dive depth, dive duration, and dive shape. I remember that gannets perform these V and U-shaped dives, and there's a V-shaped dive on the left and a V-shaped dive on the right. And so this bird is diving down to about 10 metres, and for 10 seconds of that 15-second dive, it's actively hunting at the deepest part of this dive. And we think this might be fairly costly compared to what's presumably quite profitable, go and grab the fish and off you go. And then she related these various metrics to these seasonally persistent fronts across 2 different years. And nicely, it was 2 different years that had quite a range of variation in the intensity of stratification, therefore the strength of these frontal features. And the take home from this was that gannets tend to have shorter dives when they're at fronts, and moreover, they were less likely to engage in these presumably quite costly U-shaped dives. And so this gave us some indication of why these birds might be favouring these frontal regions if they're working perhaps a little bit less hard in areas away from France. So that's the oceanography bit. The other thing we're interested in, of course, was how these birds interact with fisheries. I've already mentioned that this is a species which associates quite closely with fisheries, and when we started to attach hardware, we were really reaffirmed that view. So these are the kind of bits of footage we got from digital videos. This is a kind of typical view of a gannet coming in behind a beam trawler. And in this case, taking a red gurnet. And actually, in many cases, we find that the birds were taking gurnets out of the net, and they wouldn't actually go to discard at all, and then coming back out to the surface and eating it. And so we actually used a suite of different techniques to try and understand these interactions in a bit more detail. So we had GPS on the birds, we made use of GPS on vessels by the vessel monitoring system, we used stabilised tone analysis, where we used cameras that were both video and stills. I worked quite closely with two academics, Matt Witt and Rich Inger, to kind of delve into this problem in a bit more detail. And the kind of take-home is that scavenging is really common. These birds, as we expected, are really very closely tied to the activity of fisheries. And these are all stills taken by gannets. And this is an unadulterated, uncropped, untouched picture taken by a gannet and a fishing boat. And I think you've got to give them some props for that. I mean, that's the composition. It's not quite the rule of thirds, but I mean, it's not bad. It's a little bit out of focus, but I think, I think I'm impressed. So they scavenge very commonly, but there's also some detail there. So males are significantly more likely to follow fishing boats than females are. And also, if you take account of these sex effects, even within the sexes, there's strong inter-individual differences in the extent to which these birds scavenge. And you can find that if you look at isotopes. So this is a sire plot with a proportion of discards on the Y and individual on the X here. You can see there's quite a lot of variation, with some individuals relying more heavily on feeding or discards compared to others. And moreover, if you track the same individuals repeatedly and look at their association with fishing vessels, you get some birds which are real kind of, I wouldn't go as far as saying obligate scavengers, but they really are kind of honed in to following fishing boats much more than other individuals. So what does all this mean? A big deal in Europe is there's currently a ban on, or a phased ban on discarding, and it's being phased from 2015 to 2019. And I think most people would agree this is clearly a very good thing. However, there could be knock-on consequences, and for these communities, gannets and other species of birds that have become dependent on this subsidy, there could be unintended consequences. And these unintended consequences, from our work, are unlikely to be evenly distributed across the population. There could be some individuals more likely to be impacted than others, and in this instance, it seems that males are more likely to be impacted than females. As a footnote, that doesn't seem to make a jot difference, so we're still doing this work, and for example, last year, when the discard ban really should have been kind of taking quite a big hit, these birds were still following fishing boats. There's still lots of other birds doing the same thing, and they were catching fish. You can see they were taking discards. And in fact, if you look overall at the percentage occurrence of the main prey items, I'll just point out these blue bars here are discarded whitefish. The birds can only really get from back of fishing boats of benthic species. And there has been no real drop. In fact, in 2017, it's one of the highest years we've had in terms of percentage occurrence. So, no clear effect with discard ban yet. There's also implications here in terms of marine spatial planning. One of the things we've done was to look at the spatial response of these birds to fisheries, and gannets will respond to a fishing boat around 11 kilometres away. And that means that the fishing vessel has a much larger footprint than a single point in space and time that you might otherwise imagine. They have a spatial footprint of anything up to 300 square kilometres. I'm just going to kind of move away from this focus on this single colony, and I'll talk about some work that we did across multiple colonies in the UK, France and Ireland. In 2010, Ewan Wakefield and Tom Bodie coordinated a virtually simultaneous tracking of gannets from 12 colonies, around 200 individuals. And the kind of startling finding of this study was the fact that these birds showed strong evidence of segregation to be a function of two things. Firstly, competition both within and among colonies, where you have a halo which pushes out as the colony gets larger, and then that gets forced in a kind of lozenge shape when that halo kind of collides with a halo from another colony. But another important component of this segregation is social information. In fact, if you build some individual-based models, the only way you can really derive a similar scenario of segregation at sea is where these birds are using a combination of personal information, personal memory, and a combination of social effects from the colony acting as an information centre and the birds using local enhancement when they're far out at sea. This also means that these colonies represent different management units when they're at sea, which has major implications in terms of, for example, assessing the impacts of offshore renewables. How you all do? Good. Right, about 10 or 15 minutes ago, so just so you can be know on the straight, and then the coffee is not that far around the corner, okay? So, another area that we've found to be quite interesting and quite fruitful has been tracking immature gannets. Immatures come back to the colony in quite large numbers. They don't breed for the first time until they're at least 5 years of age, and they're relatively straightforward to age in the first 4 years of life based on plumage morphology. And we decided to put some tags on these birds as a bit of a kind of pilot, and we found that it did some interesting things. One of two things. 2 and 3 year olds, there was no kind of obvious age difference, was they either went on central place foraging trips and looked much like the adult breeders did, and they were just kind of going out, commuting and coming back to the colony, or they were prospectors. And this sparked quite a bit of interest. In fact, there's a fellow at Glasgow University, Jana Jeglinski, who her fellowship is all about trying to understand a bit more about this process. And she's coordinated deploying tags on immature gannets across 3 gannet trees: Grasshome, where we're focused, the Bass Rock in Scotland, and Helgoland in Germany. And this is very much a work in progress, and I wouldn't want to steal Jana's thunder, but the take-home message that these birds are prospecting very, very widely. In some instances, we've got birds visiting 10 different gannet trees in the space of just a few weeks, so they're building up a very detailed pattern of the potential opportunities for recruitment later in life. There was also no evidence of segregation by colony in the same way that we found for breeders. And importantly, therefore, that these immatures are not acting as distinct management units when they're at sea. Now, for the birds that were acting as central place foragers, we were able to delve a little bit more deeply into the processes that might lead to that individual site fidelity by comparing immatures with breeding birds. I'll remind you that breeding adult gannets show strong site fidelity when they're foraging from the central place, and this site fidelity is maintained across multiple years. So they have these similar routes, similar destinations. There's variation obviously, but by and large these birds tend to be quite repeatable. But if you contrast that with example tracks of 4 immatures over the same period, they're still central place foragers, but they really are much more itinerant in terms of where they go. Very, very low route fidelity, very low foraging site fidelity. And one explanation for this is that foraging site fidelity, in fact I think it's probably any sensible explanation, is that foraging site fidelity is a learned process, and we would argue that actually maybe this learning of foraging site fidelity is an important component of age at first reproduction and why these birds have extended maturity. So I think the paradigm is that improving your foraging competency with age, I think is well established, but we would just say that maybe foraging site fidelity is one important component of that development. So, Another thing that we've been doing, of course, this is projects about seabirds not having borders. Gannets are no different. We've done a little bit of work on studying their migration, mostly by a PhD student, James Grecian, who he's gone on to postdoc, but he's still not good enough to work. That's another story altogether. So James made use of geolocators and did some nice work, even though not good enough. And they're going to take home with gannet migrations, they show a diversity of strategy. So this is a summary plot of migration or core wintering grounds of gannets tracked from Grasshome, here, but also in La Rosique, which is in the north coast of Brittany, just across the water. This represents data from about 45 individuals. And the point is there's a diversity of strategies. Some gannets stay relatively close to home and they're really not migratory at all. Others will move to the coast of Iberia, others to West Africa, and a small number into the Mediterranean. And when we track these birds across multiple years, they tend to be highly repeatable. They're very repeatable in terms of their location, the latitude in year 2 and year 1, strongly correlated as is longitude. And also interestingly, they tend to have highly repeatable home ranges from one year to the next. There's also sex differences in terms of migration. So West Africa, which is this major eastern boundary upwelling region, the Canary Current large marine ecosystem, appears to be quite important for gannets. And about 60% of male gannets go to West Africa. However, about 90% of females go there, so this seems to be particularly important for West Africa. Now, what are the implications of this? The West African region, or as I say more specifically the Canary Current large marine ecosystem, has a dubious honour of having the highest levels of illegal, unreported and unregulated fisheries in the world. Now, how they know it's the highest level when it's illegal, unreported and unregulated, I'm not entirely sure, but I guess that's a question for a fisheries scientist. But I think it's fair to say that things are pretty bad off the west coast of Africa. I have colleagues who work out there and they describe it as being like the Wild West, and kind of anything goes. There's some crazy stuff happening there. And amongst that, there's very, very high levels of seabird bycatch. And then people have, on numerous occasions, there's been freezer containers which have been impounded containing thousands of dead seabirds prepared, presumably for the Asian food market, which is certainly being shipped out of Asia. And amongst those holds, there's very large numbers of gannets. Now, people are not sure whether that's targeted catch or whether it's just bycatch and it's opportunistic. We're not entirely sure. The point is that bycatch is very, very high in West Africa. And we seem to be picking up what might be a signal of this at the population level. I've got a current student, Zoe Deakin, working with a postdoc, Reece Shirley, calculating overwinter survival probability from mark gannets on Grasshome. And they're finding a significantly different overwinter survival probability for males and females. In fact, female mortality is twice that of males. And if you put that into a ppm, that doesn't make particularly clever reading. This graph hasn't come out properly, but this is a ppm for the Bass Rock, which is kind of, in theory, not being impacted in the same way. The population is increasing over 10 years from its current 80,000 population. And this is the trajectory from Grasshome. There should be confidence interval on this, but no males, and this orange line is females. So if this is indeed correct, if this is indeed connected with bycatch, it seems that this is having a population level impact. So, 2 more minutes. Where are we going with all of this? I hummed and hawed about putting this graph up, but an undergraduate student just before I came here sent me this plot, because every year we record lots of biometrics, we never really do very much with it. And I had a student who was quite interested, so well, can I have a look at it? And so he looked at, he just did BMI, and he found quite a convincing negative correlation between BMI of male gannets and average summer wind speed. The point being is that we collect information without any necessarily clear goal of what we're going to do. And I wonder whether we might have kind of stumbled on something which is going to be quite interesting. It might prove to be an experience, I don't know, but I just thought I'd mention the fact that sometimes science can be opportunistic. What is a bit more structured is we are interested in the impact of wind on these birds. So I have a studentship which is hopefully going to be starting in September, looking at the impact of wind on movement in these birds, and also impact on risk, how changes in wind might impact their risk of collision with wind farms, for example. We're also doing work on flight height, so we're putting altimeters on these birds, and we're looking at how they, whether they extract energy from their environment to fuel changes in altitude, which is an important component of their searching strategy. So this is a trace of the bird with an altimeter. Grass is here, and this coloured trace is the outbound trip of this bird, travelling up to 60 metres at a time, engaging in a search and then commuting back low over the sea. And when you look at accelerometry data, these gains in height, the birds are working really hard to actually gain these kind of heights. And you can see from the videos as well, they're gaining height and they're searching. You can see that the head's turning, and they presumably see something, that's them off. So this is part of their search strategy, but it's also coming at a cost. We're also particularly interested in social foraging. I know several people at this conference are doing much the same thing. And you find some interesting patterns. So, for example, this is not speeding up, but it's quite quick. So this is an individual gannet which goes in after a shoal of sandbars, catches one, comes up to the surface and it's on its way. But you see this much more commonly among gannets. You see birds joining these large aggregations of other gannets, often chasing shoals of larger fishes, of herring and mackerel. And one of the things we're quite interested to know is this degree of sociality to them which is consistent in time. So if you're if you're a bit of a lone wolf, you're always a lone wolf, or if you're a bit of a socialite, you always go for these social groups. And moreover, we're not sure whether this social interaction might actually be eroding some of the individuality that you see in terms of, for example, foraging style fertility. So these are just some kind of areas that we're looking into in the future. So just to wrap up, I mean, really this is all about understanding where these birds go, why they go there and what it means. But hopefully I've convinced you that biology is more than just this, it's more than just about where stuff goes and what it does. There is value there in terms of monitoring, I believe. Certainly in terms of identifying key habitats, monitoring risk, and also monitoring change. And maybe you're already doing this, I'm not trying to suggest I'm very real, but I just think that biology can be thought of more holistically as a monitoring tool perhaps than it is at the moment. I also couldn't help myself, I wanted to mention something here about future funding. So we have had some grants to fund this work, but most of it's been quite a bit of a shoestring. It's amazing what you can get done with a bit of blind optimism. But I want to tell a bit of a call out there about how people fund their work. How does a kind of a 3-year, 2-year study turn into that longer-term study, and then how does it eventually turn into that kind of George Dunnett, Henri Reimer's goes to a 25, 30, 40-year study. Ultimately, how do we actually achieve that? I'm also going to put my hands up and say, I did this because it was fun, and I make no apologies for that. And in fact, in some respects, the fact that it's fun and I enjoy it really does help you along in those times when, for example, the funding was not there, you get another rejection letter. Oh well, we'll just do something anyway. And also it's about people. So doing this field work, it's hard work, it's smelly, it's tiring, it's horrible at times. Doing the kind of number crunching is a pain in the arse. But it works because you do it with people. It works because you end up with like-minded people. And this slide's going to take a while to load up because there's loads of pictures on it. But I just want to say, I've got to say thanks to people some of the people that have funded this work. I just want to say a big thanks to all of these people and many others, because it's really people that make this stuff happen. And particularly this couple here, so this is Greg and Lisa Morgan, who are the wardens of the island. When we first went out in 2006, they thought we were mental. They were not going to go anywhere near a gannet. They don't live on grass, they live on an adjacent island. They're mostly farmers, actually. And they certainly weren't going to get their hands on a gannet. But now, Greg catches the birds, he puts the geolocators on, Lisa puts the GPS tags on, puts the cameras on. They're very much part of the team, and that's been a real kind of real bonus for us. So, thanks to people for being good human beings and for making this lots of fun, and thanks to you for listening. Cheers.